So the simplest construction that allows us to make new topological spaces is a subspace, right? So if we have a topological space, so notice that so this is X comma TOA. So this TOA is our topology, is the collection of open sets. And consider some subset of X. So A is a subset of X. Then the idea here is that initially we have a topology on X. So we know which subsets of X are called open. So these topologies, this is a topology on X. But in A, we do not really know which sets are called open and which sets are not called open, right? So A is kind of is supposed to be a new topological space. And here is what we do. So if we have so open sets of the subspace topology on A are just those that are intersections of A with an open set in X. And A is equipped with this topology. It's called a subspace of X. So that's the idea. So let me show you how it works on a couple of simple examples. So a real line and a subspace topology on the interval from 0 to 2, right? So the closed interval. Now, this is a very good example because it illustrates that open sets on this interval are not the same as open sets on the real line itself, right? So, for example, so let me just draw it. So if this is my real line, so X, then let's say my open interval is going to be from closed interval from 0 to 2, right? So this is from 0 to 2. I don't know. So this is going to be 1, 2, 3, 4, -1. Right? So my open interval is going to be from 0 to 2. I'm going to do it like this. Now, let us think of some open set in on the real line. Let's say the interval from -1 to 1. Right? So the intersection of the interval from -1 to 1 with our A, so our A is the interval from 0 to 2. From 0 to 2 is going to be, well, so where is it? So let me just do it in different color. So we take the interval from -1 to 1, and this is the interval, and the intersection of the two of them is here. But in this intersection, so notice that the left point is included and the right point is not included. So the intersection is actually, it looks like this. So this 0 is included and 1 is not included, right? So the intersection of the interval from -1 to 1 and from 0 to 2 is the interval from 0 to 1, including 0, but not including 1. Right? And this is supposed to be an open set in the subspace topology. So open in the subspace topology. Subspace topology on the interval from 0 to 2. Right? But if you look at this interval if you look at this interval from 0 to 1, including 0 and not including 1, then you will see that it is not open in the original ambient space, in the original real line, right? So this is, but it is not open in R. My point being is that the subspace topology is not the same as kind of what you can have an intuition for, right? So it's not the same as the topology on the original ambient space. Right? So with respect to the subspace topology, the half open interval, when it is considered as part of this closed interval, is going to become open now. Okay, so this is my first example, and here is my second example. So if you think of the real line as the x-axis in the plane, right? So let me draw a picture. So this is going to be my plane. So my subspace looks like this. So let me make it thicker. This is what it looks like. So this is my A. So my A is R. Okay. So now let us think a little bit. So what kind of open subsets we are going to have? So an open subset of R is the intersection of an open set on the plane with my real line, right? So open sets in the real line, they are made of disks. So let us think of an intersection of a disk with in the plane with my x-axis. But this intersection of a disk on the plane with my x-axis is actually going to be an open interval on this x-axis, right? So which is why in this case the subspace topology on R is just the usual topology on R. So it just happens that, in this case, we do not get any counterintuitive results, right? So in this case, the subspace topology is the same as the standard topology. So that is familiar from real analysis. Right, so this is the standard topology that you know from real analysis 1. And sometimes the subspace topology is just familiar, is whatever you're used to. Sometimes it's going to be a bit different, and you need to be careful about it. Okay, so but this is the subspace